Hello and welcome students in my video lecture series on the subject of botany. And in today's video lecture we will focus on class 12 and we are discussing the molecular biology part of class 12 botany. In the previous lecture we have discussed about the properties of genetic material and the RNA world hypothesis. Before that we have discussed about the Watson and Crick model of the DNA, a famous model that explains the structure of DNA. तो हमने उस स्ट्रक्चर में देखा कि जो डीएनए जो है ये डबल हेलिकल स्ट्रक्चर है. नॉट ओनली वॉटसन एंड क्रिक एक्सप्लेन द स्ट्रक्चर ऑफ द डीएनए, दे आल्सो प्रपोज्ड द स्कीम ऑफ द डीएनए रेप्लिकेशन, दैट हाउ दिस डबल स्ट्रैंडेड डीएनए रेप्लिकेट्स. एंड उन्होंने क्या बताया, उन्होंने जैसे ही उन्होंने स्ट्रक्चर ऑफ डीएनए दे दिया, जैसे ही उन्होंने अपना मॉडल ऑफ डीएनए दे दिया, उसके साथ ही immediately they explained how the process of replication takes place in DNA, and they said that during the process of replication the two strands of the DNA they get separated from one another. For example, we are having a double-stranded DNA molecule. This is a double-stranded DNA molecule, and during the process of replication the two DNA strands they get separated. This one parental DNA strand, this is another parental DNA strand. We were having a double-stranded DNA molecule. What happened during the process of replication? At the process of replication, the two strands of the DNA they separated, and they act as template for the synthesis of new DNA. And see, this is the newly synthesized DNA strand, and again here this is the newly synthesized DNA strand. So it means that during the process of replication a DNA molecule separates into two strands. Each strand of the DNA acts as a template for the synthesis of new strand of the DNA, and from one DNA molecule we get two DNA molecules, two double-stranded DNA molecules, and in the two DNA double-stranded DNA molecules that which we have got from a parental DNA molecule, each such DNA molecule has one parental strand. See, this is parental strand, this is new strand, this is new strand, this again parental strand, and this is new strand. Here I will explain you again. We were having a double-stranded DNA molecule. Before the process of replication to begin, the two strands of the DNA they separate. This is one strand of the DNA and this is another strand of the DNA. These two strands of the DNA they act as template, they act as parental strands. From these two strands they act as template strands. They are copied to form new strands of the DNA. From this molecule, this template strand, we get this new strand. From this template molecule we get this new strand. So in each newly synthesized DNA molecule we are having one parental strand, one newly synthesized strand, one parental strand, one newly synthesized strand. This mode of replication where a DNA molecule separates into two strands and each strand acts as a template for the synthesis of new DNA strand, and each newly synthesized DNA molecule has one parental strand and one newly synthesized strand. This mode of replication, this scheme of replication is known as semi-conservative. Remember, this scheme of replication is known as semi-conservative mode of replication, or simply this is called as semi-conservative replication. Watson and Crick explained the semi-conservative, they explained the semi-conservative mode of replication of the DNA, where a DNA molecule, हमारे पास एक double stranded DNA molecule था, ये दो strands है, these two strands they get separated, ये एक strand अलग हो गई, ये एक strand अलग हो गई. Now these separated DNA strands they act as template, they act as basis for the synthesis of new DNA strand. Here from this template strand we get this newly synthesized strand, and here from this template strand we get this newly synthesized strand. So we get from one DNA molecule we get two DNA molecules, and in each newly synthesized DNA molecule we are having one parental strand and one newly synthesized strand, one parental strand and one newly synthesized strand. This mode of replication where each new DNA molecule has one parental strand and one newly synthesized strand is called as semi-conservative mode of replication. This semi-conservative mode of replication was later on verified by a number of scientists through their experiments, and the most common experiment that explains the semi-conservative mode of replication in E. coli in prokaryotes was done by two scientists. One is called as Matthew Messelson and Franklin Sittel. सबसे पहला मैंने आपको बताया सेमी कंजर्वेटिव मोड ऑफ रेप्लिकेशन ऐसा मोड ऑफ रेप्लिकेशन है, ऐसा तरीका है रेप्लिकेशन का जिसमें एक पेरेंटल डीएनए मॉलिक्यूल के दो स्ट्रैंड्स अलग अलग हो जाते हैं, दोनों स्ट्रैंड्स एज टेम्पलेट एक्ट करते हैं फॉर सेंसेस ऑफ न्यू डीएनए मॉलिक्यूल, और हर किसी नए डीएनए मॉलिक्यूल के अंदर आपको एक पेरेंटल स्ट्रैंड मिलती है और एक न्यूली सिंथेसाइज्ड स्ट्रैंड मिलती है. इसी को हम बोलते हैं सेमी कंजर्वेटिव मोड ऑफ रेप्लिकेशन. सेमी कंजर्वेटिव मोड ऑफ रेप्लिकेशन was later on verified experimentally by a number of scientists, and a clever experiment in case of prokaryotes, in case of Escherichia coli, was done by two scientists. One is Matthew Messelson and another is Franklin Sittel. They did their experiment in the year 1958. These two scientists, this experiment is commonly called as Messelson and Sittel experiment for semi-conservative mode of replication in case of prokaryotes. For semi-conservative mode of replication in case of prokaryotes. So Messelson and Sittel, they did their first experiment to prove that yes, semi-conservative mode of replication, yeah, DNA replicates semi-conservatively. And what Messelson and Sittel did, they took Escherichia coli and they cultured this Escherichia coli on a medium of ammonium chloride. Remember, what was their experiment? What was the experiment of Messelson and Sittel? One thing is clear, that they cultured E. coli. Remember, this experiment was performed on E. coli. They cultured E. coli on a medium containing ammonium chloride for an indefinite period of time. But remember that this ammonium chloride has an isotope form of nitrogen, that is heavy nitrogen, N15. Remember, we are having normal nitrogen which has a molecular mass of 14, but the ammonium chloride that was used by Messelson and Sittel to culture this E. coli is having the heavy nitrogen, the isotopic form of nitrogen, that's N15, for a number of indefinite time period. What happens? That this E. coli has a tendency that it utilizes this ammonium chloride having this heavy nitrogen, N15 nitrogen, and this N15 nitrogen, it gets incorporated into the DNA. Besides, it gets incorporated into all the substances or the biomolecules that are present in the E. coli, where nitrogen of which nitrogen is a part. Remember, this N15 not only gets incorporated into the DNA, but it gets incorporated in all other biomolecules where nitrogen is present, because this medium has N15 ammonium chloride. The E. coli is cultured on N15 ammonium chloride medium. So what happens? After a long time period, the DNA was isolated from this Escherichia coli, and this DNA was exposed to this DNA was then undergone a centrifugation process. This DNA has undergone the process of centrifugation. This DNA was undergone a process of centrifugation, during which DNA जो है वो sediment करता है on the basis of centrifugal force based upon its density, and they used a special centrifugation that is called as cesium chloride, CSCl density gradient centrifugation. Density gradient centrifugation. Remember, density gradient centrifugation. Cesium chloride, the DNA was put into cesium chloride cesium chloride density gradient centrifugation. The DNA has undergone cesium chloride density gradient centrifugation. What is it? We are having a centrifugal tube. In this centrifugal tube, we insert cesium chloride solution. Then we centrifuge, we apply centrifugal force. This cesium chloride solution forms a density gradient in this centrifugation tube, where the maximum density is present at the bottom of the tube, whereas lowest density is present at the top of the centrifugation tube. This is centrifugation tube in which we have inserted cesium chloride solution. Then we have applied centrifugal force. As a result of this centrifugal force, this cesium chloride solution forms a density gradient within the centrifugation tube, where at the bottom of the tube we are having maximum density of the cesium chloride, while as top of the tube we are having least cesium chloride density. So we have what they did, they cultured E. coli on an ammonium chloride medium for an indefinite period of time. This ammonium chloride was having nitrogen 15, heavy nitrogen. When then DNA was isolated from E. coli, this DNA has this DNA has undergone this cesium chloride density gradient centrifugation, and in this density gradient centrifugation, DNA forms a band with respect to its density in this cesium chloride density gradient centrifugation tube, and this DNA gets sedimented close to the bottom, because now this DNA in this DNA of E. coli, N15 has now incorporated instead of N14. So all the DNA that was present in the E. coli is heavy DNA having heavy nitrogen N15. After that, what they did, they then changed the medium. They are then begin to grow this E. coli again on a medium, but this medium of ammonium chloride. Now this ammonium chloride having nitrogen 15 earlier is now replaced with ammonium nitrogen 14. It is now replaced with nitrogen 14. Normal ammonium chloride, normal nitrogen is there in the ammonium chloride. Earlier we were having N15 in the ammonium chloride. Now the N15 ammonium chloride solution was replaced with N14 ammonium chloride solution. And what they did, they cultured this E. coli for 20 minutes on this ammonium chloride medium having N14 nitrogen. Again the DNA was isolated from the E. coli, and this DNA was put in cesium chloride density gradient centrifugation. The scientists, they got different results. Earlier we were having the band was in the cesium chloride density gradient close to the bottom, because the nitrogen was heavy nitrogen. What happens at this case is that the DNA formed band in the cesium chloride density gradient centrifugation tube at an intermediate level. It indicates that now the DNA that earlier has N15, now if it is when it is grown on ammonium chloride having N14, अब जो N14 जो है, जब नया DNA बनेगा, एक स्ट्रैंड के अंदर N15 रहेगा, दूसरे स्ट्रैंड के अंदर N14 रहेगा. इसी तरह हमारे पास एक डीएनए मॉलिक्यूल से दो डीएनए मॉलिक्यूल्स बनेंगे, और वो दो डीएनए मॉलिक्यूल्स जो होंगे उनकी जो डेंसिटी होगी वो इंटरमीडिएट हाइब्रिड लेवल की डेंसिटी होगी, क्योंकि इसके अंदर एक स्ट्रैंड N15 है, दूसरी स्ट्रैंड जो है N14 है. इसके बाद क्या किया, 20 मिनट्स के बाद एक और 20 मिनट्स में एक जनरेशन कंप्लीट होती है. E. coli की डीएनए रेप्लिकेट होता है विद इन 20 मिनट्स. जब डीएनए रेप्लिकेट हो गया विद इन 20 मिनट्स, हमने देखा वी गॉट अ बैंड. दैट बॉन्ड वाज फॉर्मड इन दिस सेंट्रीफ्यूगेशन ट्यूब एट एन इंटरमीडिएट डेंसिटी, because the DNA was hybrid. It was a combination of one strand of N14 and one strand having N15 nitrogen. This E. coli was allowed to replicate. It was allowed to grow on this ammonium chloride having N14 for another generation. That means for 40 minutes. 20 minutes में 2 DNA मॉलिक्यूल बन गए, 40 मिनट्स में 4 DNA मॉलिक्यूल बन गए. 20 मिनट्स के अंदर जो हमारे पास DNA बन गया उसमें वो हाइब्रिड DNA था. उसमें एक स्ट्रैंड के अंदर N15 सारे नाइट्रोजनस बेसिस के अंदर N15 था, दूसरे स्ट्रैंड के सारे नाइट्रोजनस बेसिस के अंदर N14 था. अब 40 मिनट्स के बाद 4 DNA मॉलिक्यूल्स बन गए. नाउ द सीन इज डिफरेंट. व्हेन DNA वाज आइसोलेटेड आफ्टर 40 मिनट्स फ्रॉम दिस E. coli, this Messelson and Sittel, when carried out ultracentrifugation, carried out cesium chloride density gradient centrifugation of that DNA that was isolated from the E. coli after 40 minutes, they found that the 2 bands were formed instead of 1 band. Earlier 1 band was formed. That band was close to the bottom of the centrifugation tube, because we were having in both the strands we were having heavy nitrogen. Now after 20 minutes, when we cultured this E. coli on N14 medium, shabash 2 DNA molecules were formed, and in both DNA molecule one strand was N15 type and another strand was having N14 DNA. So they formed band at intermediate level in case of this cesium chloride density gradient ultracentrifugation tube. After 40 minutes 4 DNA molecules were formed, and see 2 bands were observed. One band was at the same position that was at before 20 minutes, that is hybrid band, and another band was just away from the center, much away from the center, because this band represents the DNA that is having both strands, in whose both strands only N14 and N14 is present. So this indicates that this increase in N14 with passage of time, and decrease in N15 with passage of time indicates that the mode of replication in this DNA is semi-conservative mode of replication. This was the experiment performed by Messelson and Sittel. I again repeat the experiment what they did. Messelson and Sittel, they did a clever experiment to prove that DNA replication is semi-conservative. For that they used E. coli, and they cultured initially this E. coli on a medium containing ammonium chloride. This ammonium chloride were having heavy nitrogen N15, so that this N15 gets incorporated into the DNA as well as other biomolecules of E. coli having nitrogen. So this DNA was isolated from the E. coli, and this DNA was exposed to this DNA was exposed to this cesium chloride density gradient centrifugation. I told you that cesium chloride is a solution that is put in centrifugation tubes. These centrifugation tubes are exposed to centrifugal force. This cesium chloride solution, due to centrifugal forces, form a density gradient in this centrifugation tube, where the maximum density of the cesium chloride is present at the bottom of the tube, while as minimum density is present at the top of this centrifugation tube. So when DNA was isolated, when E. coli was cultured on N15 medium, ammonium chloride medium, shabash, the DNA formed band in the cesium chloride density gradient centrifugation tube close towards the bottom. It indicates that both the strands of the DNA is having heavy nitrogen N15 and N15, that is heavy nitrogen. And now the medium was changed with respect to the nitrogen. Again the medium was ammonium chloride, but the nitrogen is the normal nitrogen N14 nitrogen. N14 nitrogen ammonium chloride पे आप इसको कल्चर किया गया ई कोली को. 20 मिनट में ई कोली रेप्लिकेट करती है. 20 मिनट के बाद देखा गया कि जो हमारे पास डीएनए मॉलिक्यूल्स थे, उन्होंने पहले जहां पे बैंड बनाया वहां पे नहीं बनाया, बल्कि उन्होंने उसके वहां पे बैंड बनाया जहां पे डेंसिटी जो थी इंटरमीडिएट लेवल की डेंसिटी थी. इससे हमें ये इंडिकेट हो गया कि ये डेंसिटी अब कम क्यों हो गई डीएनए की, क्योंकि नाउ द डीएनए है इन वन स्ट्रैंड डीएनए के दूसरे स्ट्रैंड एक स्ट्रैंड में N15 मौजूद है, दूसरे स्ट्रैंड में N14 मौजूद है, एक स्ट्रैंड में N15 मौजूद है। पेरेंटल स्ट्रैंड में जो न्यूली सिंथेसाइज्ड डीएनए स्ट्रैंड बन गई है उसमें हमने इकोलाई को सप्लाई किया था N14 अमोनियम क्लोराइड, इसीलिए हमारे पास जो ये बैंड बन गया दैट बिकेम एट इंटरमीडिएट डेंसिटी। Again, the E. coli was cultured for another generation on the same N14 ammonium chloride medium. We got 4 DNA molecules. Now, the extent of lighter DNA increases with the passage of time. We got 2 bands. One band is hybrid band, intermediate band, and another band is lighter band, where both the strands of the DNA is having N14 and N14. So this experiment clearly explains the semi-conservative mode of replication in case of DNA. Remember this diagram, this setup. Similar experiment was done by Taylor et al. Or Taylor and his colleagues in the same year 1958 on Vicia faba, that is faba beans के ऊपर किया, beans to prove the semi-conservative mode of mode of DNA replication in eukaryotes and they used a mode of DNA replication in case of eukaryotes is also, they also got similar results as were obtained by Messersel and Sittel in their experiments. So this mode of this strategy, this modus operandi of replication was put forward by Francis Crick and James Watson, the 2 clever scientists who proposed the model of DNA. In the coming lecture, we will discuss the process of replication, that how process of replication takes place in case of prokaryotes as well as in case of eukaryotes. What is the mechanism of replication? What are the various types of enzymes involved in the process of replication, and what are the various setups in the process of replication? That we will discuss in our coming lectures. And I request you all to subscribe and watch each and every lecture of my video lecture series that is available on the YouTube. My YouTube channel name is Shakur Botany. Please subscribe this channel for recent and updated video lectures on the subject of botany. I thank you one and all for watching this lecture keenly and patiently. Thank you one and all.